In this video, we will try to convert the given assembly instruction to the machine instruction. Assuming that you are doing it for 16-bit mode of operation. You are doing this for 16-bit mode of operation. When you do it for 16-bit mode of operation, okay, so here you have this violation, right? There is a operand violation. So whatever machine instruction you get, you will have to append it by 66, right? Now let us convert this into the machine instruction. Okay, see this assembly instruction is same as MOV EAX, comma, it is same as BX plus DI plus 4020, right? These two are same, right? So now as usual we'll try to convert it into machine instruction. Then we'll start with the opcode. Opcode is 100010 because move instruction, this is corresponding to your opcode. D bit is going to be 1 because data is going to the register. Okay, data is going to the register, so D bit is going to be 1. This is going to be your D bit. Similarly, what is W bit? W bit is more than 8 bit. More than 8 bit, whether it is 16 bit or 32 bit, D bit is W bit. W bit is going to be 1. Okay, W bit is going to be 1. Okay, now moment you get D and W bit, you have to get the registered bit, right? Registered bit, and registered bit, which is the 32 bit register here. Okay, so you can refer to your this register table, and from register table you get this as register value as 000. Now you check what is your mode bit and what is your mode bit and R by M bit. Okay, so you have to refer to this something like this, BX plus DI plus 4020, right? Refer to this table where you will have BX plus DI plus a 16-bit displacement, BX plus DI plus 16-bit displacement. Okay, so where do you have that here? See here you have. Okay, so here you have a displacement BX plus DI plus 16-bit displacement. See, this is the one. See the corresponding R by M bit 001. See the corresponding mode bit 10. So mode bit is 10, R by M is 001. So you just put it as here. Okay, this is mode bit is going to be 10, right? It's going to be 10, and this one is just pick it from here, that is 001. It is 001. It is 001, right? Okay, so you're done. Okay, this has to be appended with the displacement, right? Now make up a 4/4 bit. Okay, so it has become now 8B81. Okay, 8B81. Then displacement. What is the displacement? Right, 4020. Right, displays 4020. So lower byte comes first, and then comes the upper byte. Okay, so since it is 16-bit mode of operation, there is a violation here. Okay, so you have to append it with operand violation, that is 66. Okay, now suppose if I ask this to be a 32-bit operation. Suppose if I ask this to be a 32-bit mode of operation. So what violation will come here? Address violation, right? Address violation. For 32-bit mode of operation, there is a address violation here. This address is now, it is 16-bit, right? For 32-bit mode of operation, this instruction has a violation of this address. Address is 16-bit. So in such case, you have to you need not put 66 here. Instead of 66, you have to put 67. Because for 32-bit operation, there is no violation of operand because it's already 32-bit, but there is a violation of address here. So this is to be appended with the 67. Right? So this is the solution for this problem. Hope you understood this. Okay? Watch it again and again. We can understand it better.